Hello, I'm Stefan Greber. I'm the CTO and co-founder of FuturFusion, an open source software company focused on building private cloud solutions. In this video, I'm gonna be walking you through our FuturFusion Cloud offering, going through what it is, how it works, and doing a pretty extensive demo end-to-end of how it all behaves. First, we're going to be looking at a high-level overview of the solution. That's what we got here. And just very quickly, what that shows is 3 different sites running FuturFusion Cloud, each site with multiple clusters. In this case, we're just showing a couple, and each cluster being made of several servers. In this case, just showing 4 servers. It also shows some services that are running on each site, things like log aggregation, metrics aggregation, as well as services that are global to the entire deployment, things like authentication services, authorization services, the observability stack with metrics and log aggregation. It also shows some of our own software in there. So besides what's running on the actual hypervisors, which is Incus running on our own Hypervisor OS, we can also see on there Migration Manager and Operation Center as other software that are part of the FuturFusion Cloud solution. Migration Manager being responsible for moving VMs from VMware over to our own hypervisor Incus, and Operation Center being there to manage the whole deployment, keeping track of all of the clusters, all of the servers, global inventory of every single VM that's running on the entire environment, etc. Now, let's go through those components in more details and just see how they work and how they kind of all fit in. So first thing first is Hypervisor OS. So that's our very secure, immutable OS image. So it actively relies on UEFI secure boot and TPM measurement through a TPM v2 module to handle system integrity and handling the encryption at rest piece of the stack using the TPM state to handle the encryption. It's also extremely reliable. So each deployed Hypervisor OS system is identical because everything is built from a read-only immutable image. And each machine has 2 copies of that image, an A and a B side, making it possible to easily revert if something goes wrong or if an image gets corrupted. You can just boot back on the other side and have the machine back up and running very quickly. We use Hypervisor OS as the foundation for all software that we run. So not just on the physical machines that then run Incus as the hypervisor, but also as the basis for Operation Center and Migration Manager, both of which are typically deployed as VMs instead. This means that the base OS of the entire solution is effectively identical, making it a lot easier to kind of validate, certify, and make sure that everything is nice and clean. All management of Hypervisor OS is done through a modern REST API. It's very locked down, so there is no local shared access or even remote access besides the API. And the API itself is authenticated either through TLS client certificates, which can typically be stored on like an HSM or the physical tokens for emergency access, or for normal day-to-day operation would integrate with the authentication and authorization system at a customer site to handle fine-grained access for specific users. Hypervisor OS itself is fully open source with the code licensed under the Apache 2.0 license. One thing worth noting is that in the rest of this presentation, you might see me use either Hypervisor OS or Incus OS somewhat interchangeably. That's because Incus OS is effectively the community side of this project. So it's publicly available, has builds that everyone can use with frequent updates. Hypervisor OS is a rebuild of that project for our own customers, with each image going through additional testing and extra security by using a separate signing authority from what's used for the open source, like the community builds. Otherwise, the actual content is identical. There are no features that are locked just for users of Hypervisor OS as opposed to Incus OS, but we on purpose use the different naming to clearly distinguish whether something has been built and signed and is being deployed at a FuturFusion customer, as opposed to someone consuming the community build of that project. The next component is the hypervisor itself. So that's Incus. That's another fully open source project that's existed for quite a while now, which provides a modern, secure private cloud platform with built-in clustering and multi-tenancy, on top of which we run either system containers, so that's LXC type containers, application containers, so your normal kind of Docker OCI type image, or most relevant in this case, virtual machines. The vast majority of our customers run only virtual machines because they're mostly moving from an existing environment running VMs on something like VMware and moving over to us. But we also do support running containers natively, which is particularly useful for some of our own internal services and for some existing workloads that a customer might be currently running on their Docker somewhere. It's not a replacement for Kubernetes. So if you are running like a full cloud native stack using Kubernetes, Kubernetes is best run on top of virtual machines running on Incus. And as mentioned a few points down on this slide, we actually have a Kubernetes cluster API plugin to make it easy to dynamically scale your Kubernetes deployment running on top of Incus. Incus supports quite a lot of options on the networking side. So both on the traditional networking, supporting normal bridges, VLANs, device pass-through, including SRIOV and VDPA, as well as virtual networking, where we're using Oven as our software-defined networking option. On the storage side, the option for local storage of choice is using ZFS. We support remote storage, so that's typically your external SAN, which we can access using NVMe over TCP, iSCSI, or Fiber Channel. And we also support software-defined storage through Ceph and Linstore. Then for our VMs and our containers, we actually support passing through quite a lot of devices as well, if you're not just using a purely virtualized stack for what's exposed to the guest. So we support passing through GPUs, network cards, InfiniBand controllers, NVMe devices, USB devices, or basically any arbitrary PCI add-in card. On the security front, our virtual machines are designed to be very modern, so they default to using UEFI with Secure Boot. We support virtual TPMs, but we also support turning some of those options off for all the legacy type guests that still need to be moved and run on top of Incus. Incus itself is entirely based around a modern REST API. It's got a very comprehensive CLI that covers the entirety of what's exposed to the API. We also have a web UI for it, and it's got integration with infrastructure as code clients. So kind of your usual stack with Ansible, Terraform, or Packer. Respectively for like deploying stuff inside of Incus VMs or containers, deploying Incus infrastructure itself, or creating Incus images. And as mentioned, we also have a Kubernetes cluster API plugin, which makes it possible to have Kubernetes clusters running on top of Incus VMs, with Kubernetes then being able to dynamically scale the number of VMs and directly on the Incus layer. Incus is also fully open source, licensed under the Apache 2.0 license. And if you want to try Incus, you can do that pretty easily on our website with an online demo that walks you through using it through the CLI, as well as letting you into the web interface as well. The next component is Operations Center. So that's really your central dashboard for a FuturFusion Cloud deployment. It is used to do the initial provisioning of servers, creating clusters from that. It handles updates, tracking, and management for all servers and applications that are part of the stack. It also acts as the global inventory. So it's going to go and look at every cluster that it manages and pull all of the VMs, all of the extra disks, all of that stuff from those clusters and making that available in just one single location. It handles license tracking on the entire deployment. And it also handles creating support bundles and other support artifacts needed to support our customers. Everything, so kind of similar to Incus and all of our other components, Operation Center is built around a REST API with both a web UI and a CLI tool to access it. It's designed with safety in mind, so we really try to have it be, retain as little permission as it can, meaning that typically after a cluster has been deployed, Operation Center no longer has write access to that cluster and can only access it read-only to pull in the resources that are deployed on that cluster and keep track of the inventory. If you want to then perform a change that requires more privileges, Operation Center is going to need to have its access temporarily upgraded, then it can perform that action, then downgrade it afterwards. The reason for that is we don't want a potential security issue or problem with Operation Center to allow taking over the entirety of a customer deployment. Each of our clusters is also effectively isolated from other clusters so that taking over a single cluster or taking over Operation Center does not get you the keys to the kingdom and the ability to take over the entire cluster environment. Now, as far as authentication authorization, similar to what was described earlier, it integrates with a normal stack, so OpenID Connect typically for authentication, and we use OpenFGA for authorization. In both cases, that means integrating with things like Microsoft Entra, Okta, or any other standard login platform, and then using typically group membership as the source of truth for the fine-grained access control, so the authorization side of things. And it's also fully open source license under the Apache 2.0 license. And the last component we're going to go over in the stack is Migration Manager. So that's our fully featured VMware to Incus migration tool. It can connect to hundreds of individual VMware vCenters as well as NSX managers. And then it pulls in the global inventory of VMs and networks at a given customer site. It then provides that overview, makes it easy to filter and look at what's going on, and then plan detailed migrations by effectively creating batches of everything that we want to migrate, setting up effectively affinity and affinity type rules between the different VMs, setting time constraints, and then setting up maintenance windows so that a migration can be scheduled in some cases over the course of several months, with a number of instances being migrated every day or several times a day, depending on when some downtime can happen. To minimize the downtime, we support incremental disk transfers whenever possible, meaning that as soon as the migration batch has been defined and started, we will start doing background disk transfers of all of the instances affected, potentially weeks before it's their time to actually be migrated over to the new platform. And every time we do one of those background syncs, we can also run the post-migration logic in dry run mode to check that we expect effectively the migration to fully go through correctly at the end. That lets us flag things like BitLocker being enabled on a given disk. That lets us detect specific instances with storage or network configuration we've not seen before that could be problematic, and flagging all of those potentially weeks before the actual migration is set to happen for that VM, so that the right actions can be taken either by the customer or by our team to ensure that the migration will get unblocked and be able to proceed correctly. We also perform what we call seamless migration, meaning that since we don't look just at the VMs, we also look at the networks, we can set up correct networks on the source and target side, including setting up turn-ons and the like between the two environments, so that a VM can be moved but retain its MAC address and IP address and effectively resume just a few minutes after it's been taken down from the source environment on the target environment, coming back, same IP address, same everything, and just pick things up where it left off. That makes it quite a lot smoother to handle very large migrations. And after effectively doing an initial round of validation for the different type of software and workloads that are in place, the rest can be mostly smooth sailing by just having VMs go down for 1 to 5 minutes, something like that, as the last disk transfer step and post-migration logic is run. And then they come back online, they're on the same network, same IP address, same everything, and they just immediately resume without needing the workload owner to be involved with reconfiguring the application or reconfiguring the network to make things work again. Migration Manager is also fully open source, released under the Apache 2.0 license, like the rest of our stack. All right, so now for the demo part of this. And first, let's just go through what the lab environment I'm using kind of looks like. So the lab has an existing VMware vCenter 8.0 environment, which is running vCenter itself, as well as 4 virtual machines. One is Debian 12, one is Oracle Linux 9, one is Ubuntu 24, it says 24.04, I think it's actually 22.04, and one is Windows 2022 data center. So that just kind of gives us a decent set of existing workloads to move over and just see how that works. Then on the target side, I've got 3 virtual machines running on an AMD EPYC server that act as virtual servers. Obviously, in the real world, you deploy everything on physical servers, but that makes it quite a bit easier to show the install process. It's also quite a bit faster, so great for a demo. On top of that, I've got 3 physical servers. Each are 64 cores AMD EPYCs with fast 200 gig, 2 times 100 gig networking. Those are physical servers, but we're not going to install them. Instead, they're already running the latest Incus OS install, and we're just going to be importing them effectively into the Operations Center we're going to be deploying. Storage-wise, they're on a mix of local NVMe and shared NVMe over TCP storage, but that's not going to be too important. We're not going to go into the nitty-gritty details of storage or networking in this demo. On the networking side, I effectively got a lab VLAN that everything is sitting on both sides, so we'll be able to migrate and keep things effectively on the same VLAN with the same IPs and everything. Now for the plan for this demo. So first, we're going to be downloading Operations Center from the download site, and then deploy it as a VMware VM. That's going to take a little while. I'll explain a bit more later, but there's some fun with the TPM handling in VMware that makes things slightly slower than we'd like. Then once it's up and running, we're going to be setting up the provisioning in Operations Center and download an Incus install ISO that we'll then use to deploy the 3 virtual systems. Once those are up and running, they'll show up in Operations Center so they can get enrolled. And after that, we'll do the same thing with the physical servers. So those just need to get provided the credentials to access Operations Center, and they'll be able to self-enroll at that point. At that point, we can create the 2 clusters, so the virtual cluster and the physical cluster. And once that's up and running, create some VMs, make sure everything works on there, at which point we can download Migration Manager and deploy it as an Incus VM. Make that go online and configure it. And finally, use Migration Manager to actually move those existing 4 VMs from VMware over to Incus. And that will be a wrap for this demo. All right, so let's go and take a look at this. Just gonna be switching to my screen here. Here we go. And let's look at what we have. So first here we can see the vSphere environment open. Those are the 4 VMs we're gonna be moving. And we've got vCenter running here. So as mentioned, the first step is going to be to download Incus OS, and specifically the Operations Center version of it. So I can go on the Incus OS downloader, just going to want an ISO for Intel. We want to install from it, and we want Operations Center. Then I need to provide here a bit of data for the certificate that we want to see trusted. So that's because in this environment, I don't have an OpenID Connect stack that I want to use for authentication. So I'm going to be relying on TLS client certificate authentication. If I had a system with like a physical token or something like that, I could use that. In this case, we're going to use a software token. So I just have a generated certificate on my system here. You can see client certificate, client key, and a PFX. So that's just a PKCS 12 version of the two of those combined. So for this, I need to open the certificate here and just in a text editor, get the content and give the public key over here and then hit download. All right. And we're downloading the ISO. Then once we've got, the ISO is about 3.4 gigs large, I think, but we're downloading it compressed, so it can download very quickly because the actual amount of data that needs to be retrieved from the download site is something around 500 megs or something like that. So once we've got that ISO, we're going to need to upload it into the data store on the VMware side, and then can create a virtual machine from that. That also takes a little while, mostly because of getting secure boot and TPM and everything correctly configured in VMware to get the secure environment we need to run Operation Center. All right, so we can already go on the VMware side and look at the data store. So I've got a local data store here. Just need that to load. Here we go, ISOs, and it's gonna get uploaded in here. We can see it actually finished downloading. So upload files and uploading the ISO. And this is ongoing, it's gonna take a little while. While this is going, what we'll do is go and create a new virtual machine here to actually run Operation Center. So I can go here, it's gonna be called Operations Center. It's deployed here on demo. Then need to pick the server, it's gonna go to over here. Okay, on the local storage pool. Here we go, ESX, and that's going to be Linux, but I'm just getting some more detailed instructions from our guide because there's some extra config that's needed afterwards that is not always obvious, specifically on the secure boot side of things. So just getting that from our docs. Okay, I've got the instructions up now. So for the OS, oops, not other, we want Linux. And we want Linux, where is it? Other Linux here, 6 later, 64-bit. There we go. Now on the spec side, what I want is, let's do 2 CPUs, 4 gigs of RAM, which is more than enough for what we need here. Let's do 50 gigs of disk, and we're gonna put that on NVMe. So let's just add an NVMe controller here. Change that disk over here to using, oops, the NVMe, a new NVMe controller. There we go. At which point the SCSI controller can go away, so I can remove that. And the ISO we'll need to select, but I think it's still uploading, so we're gonna have to wait a tiny bit for that. We're gonna want a TPM module, so add that. And we want to make sure it's doing UEFI secure boot. So EFI is enabled, we want secure boot enabled. We want it to go into secure boot on first, into EFI on first boot. And then for the less obvious part of passing through the config for this stuff. So that's effectively telling VMware how to configure secure boot in the VM. For some reason, they don't have a normal UEFI firmware menu where you can do that. Normally on a physical server, what you would do is you would go into the BIOS and then you would enroll those keys by selecting the files from the BIOS, and we've got those keys directly on the installed media. But VMware doesn't let us do that, so we need to instead do that and then directly upload those. Let's see if we can select the ISO at this point. I don't know if it finished uploading, but maybe. ISOs, yeah, it's here, the size is correct, so we're good. And I think that's all we need. So we should be good to go. That creates the VM. And then on the storage side, we just need to upload the keys that we mentioned in the config. So we actually have those on our image download server. So keys, and we need the 2025 R1 and the key enrollment key. So those two files, and then go here and upload them. They're both tiny, so that's gonna go very quick. And with that, VMware will be able to set up Secure Boot correctly. Now, if we go on Operation Center and we start the VM, okay, it's going straight into its boot menu. That's what we want. And then boot from the CD-ROM, and unsuccessful. Okay, that's possibly because it's not connected. That's the most common reason for that. Let's go see edit settings. Yep, sure enough, not connected. Forgot to tick that earlier. Okay, let's try it again. Here we go. So now it's gonna be booting into the installer. This is gonna take about 3 minutes. On a normal system, it takes about 10 seconds. But right now it's effectively trying to load the kernel image and sending all of that through the TPM for measurement. And for some reason on VMware, this is taking a long time. So while this is going on, we're gonna look at enrolling the client certificate in the web browser and maybe looking around a bit in VMware while this happens. So as I mentioned earlier, since I won't use OpenID Connect, I'm going to be using a TLS client certificate for authentication into Operation Center, but then also the deployed Incus clusters and eventually Migration Manager. So we need to load that PFX into the web browser. I'm using Firefox here, but the same is basically true of Chrome or Edge. You can look for certificates. You get to this view, which shows not only the certificate authorities here, also specific servers that were trusted in the past, but there's a tab for your certificates, and that's where you can go and import that PFX file. So cert client PFX, and then enter the password from that. And here we go. Now the web browser can use that certificate as proof of who it is, like as a client, when connecting to different services. We look here, we're still not booting. The first sign of it booting is gonna be a message saying Incus OS is starting. We're not seeing that yet. Hopefully in the next minute or so. While this is going on, we can take a quick look at what's in VMware, but there's nothing that I don't think I haven't covered yet. So as mentioned, vCenter itself is running here. We're not gonna migrate that. Pretty bad idea to try and migrate vCenter itself, so we're gonna keep it put. Same thing for Operation Center. We could migrate it, but we're just gonna leave it here for the demo. Instead, we've got a folder called test that's running Debian 12, Oracle, Ubuntu, and Windows. And all of those have the VMware guest agents running right now, so we can see the IP addresses. That's gonna be particularly interesting during the migration because we'll get to ping that IP address and see exactly when it goes down and when it comes back up after the migration. All right, still not booting up. Outside of VMware, I can show this other one. So that's effectively, yeah, we can share that, it's fine. That's the Incus cluster that's used for the lab environment. So I mentioned that we've got 3 virtual machines that can be acting as servers. That's server 01, 02, 03 that we can see here. The other thing you might notice is that VM here called EXXI. So the whole VMware environment, including vSphere, is actually not running on bare metal. It's running within a large Incus VM itself. Makes it a lot easier to kind of reset the lab and just do multiple demos and keep things clean. Obviously, in customer deployments, that would typically be a much larger cluster running on physical hardware, but it's not really relevant whether it's virtual or not. Let's see, still booting? Still booting. And you can also see 2 other VMs. I've got a Windows 11 VM running here, and I've got a ARM64 VM running here. Those are not used for this particular lab. They're just VMs I'm using for other reasons. But that was one thing that's interesting, is that Incus can run multiple architectures within a single cluster, because that VM, as mentioned, it is ARM64. So it's running in the same cluster as some AMD epics. And we can actually go and see that if we look at the cluster overview here. You can see that cluster has 3 servers. One is an AMD epic, one is an Intel Xeon, and one is a Qualcomm ARM server. Is it booting yet? It is. Okay, it actually booted and installed. That's kind of the ironic thing, is that it takes forever for VMware to do that TPM hashing of the kernel being booted. But as soon as it goes through, the installation took 18 seconds in this case, and we're done. The unfortunate part is that we're going to have to wait 3 minutes again, because now it's installed, so we're going to need to shut it down and actually booting it back up. So let's stop the VM here, and then I'm just going to go and edit its settings and fully remove the CD-ROM drive. Where is that? Oops, I'm looking at the wrong VM. That was the Debian VM. Let me just start it on backup then. And Operation Center is the one I care about right now. Okay, Operation Center. Let's go and power this off. Yes. And edit settings and remove the install media. There we go. Don't need that anymore. And then start it back up. Yep. This got disconnected. And we're greeted by a black screen again, because it very quickly got to that stage where now we're waiting 3 minutes for it to go through the TPM hashing of the kernel again. It's not a huge issue, really. It's kind of annoying during installation, because we need to do those 2 boots pretty quickly back to back. In normal operation, it just means that if you want to apply an update, it's going to take 3 minutes for the VM to come back up. Not ideal, but also shorter than any normal kind of maintenance window that anyone might have. So not a big problem. All right, so while this is happening, let's keep looking at things. Still on this cluster, I can show some of the other stuff. On the networking side, we just have one virtual network that's being used. The cluster has a series of storage options available to it. We've got a Ceph cluster providing hard disk storage, a Ceph cluster providing SSD storage, local NVMe on top of ZFS, and then a shared storage of iSCSI for some additional storage. So it's got a bit of everything, pretty convenient for our lab environment. In there also, this cluster is effectively set up for multi-tenancy. So the environment I'm showing here is called s3 so that we can see up here. But I've got several other projects in here, each with their own instances. I can see them all because I'm the administrator for the cluster, but other users might just see a very small subset of that. We use this cluster for things like demos, but also CI. The online demo of Incus is actually running here. So those VMs are the ones used for the online demo that I mentioned earlier. So overall, kind of show of how multi-tenancy works by splitting this cluster into multiple projects. Each project has some resource limits to avoid being able to run the cluster resources dry. And yeah, that provides a pretty functional cluster. In this case, a very small cluster, but with a good mix of hardware. We also have GPUs and a bunch of other things in there for the lab. All right, still going to be waiting for this one to boot. So we can go look at the physical servers. That's the next 3 tabs I've got. So those are 3 physical boxes, AMD EPICs, single socket, but 64 cores, CPUs. I think we have either half a terabyte or a quarter of a terabyte of RAM in those machines. And as mentioned, they've got dual 100 gigabit connectivity on the network side of things. So if we go look at their screen, we can see them. Here we go, loading. We can see them running Incus OS. So you can see they've booted, they've actually run and initialized Incus, and they've been ready. They're currently running the latest build of the OS. So they're effectively good to go. They're just not managed by an operation center at this point. they're just kind of standalone servers, and we're going to be adopting them effectively into Operation Center in just a little while. The other two I've got here are going to be effectively identical. It's the same hardware, same everything, also running Incus OS the exact same way. So if we look at like the third one, you can see here that it's running this. And we'll see later, but basically Operation Center makes it easy to generate installation ISOs, including getting stable links to those. That's particularly useful when installing physical servers because they support virtual media. And you can see here, I've got the option to install with the Debian image, and I also have other images available on the virtual media drive, including the one used to install Incus itself. So I was able to deploy those servers by just uploading the ISO from Operation Center onto a shared storage media that all the servers could see, and then just boot and install themselves from there. Yay, so this finally booted. We're looking at the first boot here of Operation Center. So it's downloading the application itself. Operation Center system is ready. So we should be good to go. Now I just need to go at the IP address mentioned at the bottom of the screen. So 172.17.30.251. Let's go to that. 217.30.251. Port is 8443. It's running on self-signed certificates. That's why I'm getting this. That's perfectly normal. And then it's asking whether I want to use my client certificate to log in, which I do. And here we go, we're in Operation Center. Now, the first thing it's going to do in the background is start pulling the different images that are available to it. We can see it already fetched 2 of those, and it's busy getting the third one now. So it's effectively pulling the 3 most recent images that we have, and it will then make those available to the machines that it's managing. Also worth mentioning, Operation Center can run in a fully air-gapped environment, in which case, obviously, it doesn't get to do that. But that's why we also have support for uploading images manually into it, which is what you would do in an air-gapped environment. But if you're not in an air-gapped environment, it's very convenient to just let it download the images itself. Now, if we go look at the server list, there's obviously nothing, also no servers right now, and the global inventory is going to be all empty. That makes sense. We don't actually have anything just yet. What we need to do is enroll our servers. So that means deploying from scratch the 3 virtual ones and then adding the 3 physical ones. The way we do that is by creating a new token and give it a name. So let's say demo, and we can give it a limit for the number of machines that can be enrolled through it. The reason for having multiple tokens is kind of access control to an extent. So you could have a token per site or a token per room being deployed or something like that with some limits on it, so that should it leak, it will just run out of machines and you don't get to have random systems get registered into a Operation Center. Going onto a token, you can edit those limits, but you can also create seeds, which we won't do here because for this environment, it doesn't really make sense. But if you're deploying a large number of identical systems, you can effectively pre-create predefined configurations. So saying for a given application being deployed, for example, Incus, if you're deploying a physical server, you can make the configuration public, which then gives you a public URL for the install ISO that can be fed directly to the BMC of the server, so something like an iDRAC or ILO, and have it boot directly from that and install. So you can provide network configuration, some more install configuration as well through that. As mentioned, we're not going to be using that because we're only deploying one fixed type of thing, which is the virtual servers. And then for the pre-existing ones, they don't need to use that mechanism anyways. So if we go back to the token list, there is an icon here to download an ISO from that token. We're going to want an ISO to install. That's typically what you want for virtual machines. And for physical machines using virtual media. If you're manually installing a machine, you're probably going to want USB instead and get a USB image you can put on a thumb drive. So we're going to do ISO for Intel. We support ARM as well, but we're going to go Intel. The install drive can be wiped. If there's any data left, that's fine. If there are multiple drives, we can tell it what drive to use for installation. Then the application we want is Incus, and the network config, I actually have one ready. Leaving it empty would be fine. It would just do the HTTP on everything, but I've got one that's slightly tweaked that we can use. That's this one. We can see single interface. It's turning on LLDP, so we can easily see what switch we're connected to. And it also configures some roles on the interface, specifically adding the instances role, which is used to then put Incus VMs directly on that physical network. So that just saves us from having to configure that after the fact. Whoops, clicked away from the download form. Let me just do that again. Okay, so we said Incus and then the network config. All right, and after that we get to just hit download, and we can see it's preparing the ISO and will then download it for us. At which point I just need to attach it to the three servers that are acting, the three VMs that are acting as servers here, and boot them up to trigger the installation. Those servers, if we go look quickly at their config, I like to do the YAML view to see everything in one shot. We can see they've got 8 virtual CPUs, 32 gigs of RAM. They've got Secure Boot marked as disabled. It doesn't really disable Secure Boot, but it puts it into setup mode, which is what we need to do the automatic key enrollment that comes with our image. And then the rest are just internal volatile config keys we don't need to look at. And we can see it's configured to access VLAN 3000 for its network interface. It's got a virtual TPM added and got 200 gigs of storage configured on it. All right. So I think I just saw, yeah, download is starting. So yeah, there we go. We've got the ISO. Now for the actual setup, we're gonna switch to the Incus command line, just so I can kind of show both over here. So I'm already in my downloads folder. This ISO is named after the token that was created, so we need to upload that. So we can do that with Incus storage volume import to the local storage pool, name of the ISO we want to import, and then call it Incus OS install. It's an ISO, and I want it on the same server that's got the VMs. Since it's going on a local storage pool, it needs to go on the right one. If it was on a shared storage pool, it wouldn't matter. So that's just uploading the ISO. Again, it's 3-point-something gigs large. So that's just getting uploaded into Incus. And then we can attach it to those 3 VMs, start them up, and they're going to go through the install process. All right, that's the ISO uploaded. Just doing some validation. We'll be good to go. All right, now I'm going to be adding it to the different VMs. So add it to server 1 as a disk called install. It's a disk. It's on the local pool. The volume is called Incus OS install. And I want a high boot priority on it so that it boots directly from it and not attempts to boot anything else. So we do that on server 1, server 2, and server 3. And then we can start them. And I could go in the web UI to show you what they're doing, but we can also do it directly from the CLI. So telling the CLI we want to see the VGA console of server 1. And we can see it boot right now. And just to give you a bit of an idea of the difference when the TPM works at a normal speed, it's currently doing the same hashing and it's done. Incus OS is starting, so we're in the installer right now. Significantly faster than what we're seeing on VMware. So it's going through the same install process, just effectively copying the install media onto the drive. That takes just a few seconds, and then we'll be done. Here we go. This is complete. I'm just gonna go and check on in server 03, making sure they're all done. Yeah, it's still installing. Okay. And that's done. All right. So let's just check 02 just to be safe, but I think it's gonna be fine too. Yep. Okay. So let's just stop them all. 1, 2, 3, and then gonna go and device remove server 01 install like that. Same thing with 2, and then same thing with 3. Okay, and it's time to start them back up. 1, 2, and 3. Okay, let's go look from the UI instead. So we can see them all as running. Let's take server 1 and let's go look at its console. Okay, Incus was starting. So on first boot, they actually go through repartitioning to actually get access to the entire disk that's on the system, and also initializing the encryption key, tying it to the TPM, doing a few kind of steps that are needed on first boot. So it takes a bit longer on that one, but still just a minute or so effectively to go through that process, at which point the Incus OS UI, this shows up and it just completes the process. So right now it's generating the encryption recovery key, which is going to be needed should something change that breaks the TPM state. Then it goes and actually connects to the network, so we're seeing right now, and then goes on to download the application. So in this case, Incus. The difference from what we've seen earlier with Operation Center is that now it's downloading through Operation Center. It's not going directly to the internet. That server is not touching the internet at all, effectively. It's doing everything through Operation Center. Then Incus is starting up, initializing, and then the one before last message, server registered with the provider, means that it's registering with Operation Center. And then we can see down here, the warning that was showing that the encryption key had not been backed up yet has gone away. That's because Operation Center automatically backs up the recovery keys for all servers it manages. So that's up and running. We can see its hostname is currently 5D-AAA. That's kind of useful to then go look here on the server list, where we can see all 3. And that effectively tells us whatever it is. So we could do virtual 01. So we just kind of know which is which. The name they have is not actually random. It's based on the UUID of the firmware for that server. So it's kind of effectively an asset tag that's fixed for that machine. But I still like giving them shorter names just for convenience. So if we look at 02, the name for 02 is F77. So that's going to be virtual 02. There we go. And that obviously means that the last one is virtual 03. So let's do that. And we successfully have our 3 servers. Now, adding the physical ones, that's a bit trickier. We're actually working on adding, because it's still a pretty new process, we're still looking at adding a CLI, a UI option to get the data we need. Because what we need to do is go back here and go on a machine that can access them. And then there's the admin, so Incus admin OS command we can use to modify what we call the provider config on each of the server. So the first one is called Azuras. And currently its config is to access the public image server and not talk to Operation Center. We need to change that a tiny bit. And for that, I just need, I'm going to do that off screen real quick, but I need to go on one of the servers that we just installed and grab the data that was used to do the enrollment and then add it to that. Again, that's something we're actually working right now on adding to the UI, which will make it a tiny bit easier to handle in the future. All right, I got it. So what we need to do is the name here becomes Operations Center, and then the config is what changes, and I just got a copy of it from one of the existing servers, so that's what it looks like. Just need to indent that correctly, and here we go. So the server certificate is just the public certificate of Operation Center. Since it's using a self-signed certificate, we need to enter it that way. If it was running on a valid TLS certificate with a valid domain name, then the certificate could be omitted, at which point you just need to provide the token string. That's what we created in the UI earlier. and then the URL of the server itself. I'm just gonna make a backup of that config because I'm gonna need it for the other servers. If I save that and go back here and refresh, we've got an extra server that just showed up. And we know that this is, oops, Azurat. That's the host name of that dev system. There we go. And then rinse repeat with the other two. So let's do NTAC is another server. Do that here. All right, save that. We should see another server just showed up now. There we go. And rename that as well. So that becomes NTAC here. Save. Go back to the server list. All right, rinse repeat, last one. And here we go. Again, not something you're really likely to do in a production environment, because in a production environment, you're going to want to install the servers just like I did with those 3 VMs. But in the event you do have machines that need to get enrolled into Operation Center later on, that's kind of the way to go. And we can now see we've got a total of 6 servers in there, 3 virtual and 3 physical. The next step is to actually create Incus clusters. So we're gonna go and do that. So clusters tab, and let's start with a new cluster, a new virtual cluster. Actually, I forgot to get the IP address here. Normally in production, you would want to use a load balancer in front of the cluster so that you have a stable DNS record that points to the cluster, and that will work even if some machines go down. I don't have that here, so I'm just gonna use the IP address of the first machine in the cluster as the public contact point for it. Select the 3 machines that I want to put in there. Service config would be if we had to configure NVMe over TCP or iSCSI or something like that. We don't need to do that here. The application seed I do need to provide, and I've got one ready. The only thing that I'm putting in mine is the client certificate that it needs to trust, which is the one for my web browser. So it actually trusts me and I can access the cluster after it's deployed. But that's also where you could create additional networks and storage pools and put configuration for OpenID Connect, all that kind of stuff could be included in that config here. And we actually have another feature that you can see in the menu here called cluster templates, where a very complex config can be put together and then only leaving a few variables in it so that when you deploy a cluster, you can use the from template option at the top, which then only asks a few very specific questions and the rest of the configuration is generated for you. That's what we would normally do for customers, where our team would work with the customer to put together those templates. And then when deploying new servers, that's what would be used. And the only questions would be something like, what storage array do you want this to be connected to? What's the network name? Those kind of things. And then the rest would be already preset. Anyways, putting the config here and then can hit create. And that's going to take a few seconds to go through. In the backend, it's connecting to the 3 different machines, initializing a cluster on the first one, joining it from the other 2, and then generating a Terraform config that is then being run to apply the remaining configuration. So storage, network, the certificate, all that stuff is pushed through Terraform. And we then let you download the Terraform state directly from here to include it, if you're doing infra as code, include it in your CI/CD pipeline so that from this point on, you can manage all of the cluster objects in configuration by using that as the initial state. All right, time to create the second cluster. So we'll call that physical. I once again forgot to get the IP address of the first server, so let me do that. Cluster, create physical, that's the IP address, all 3, and then the application seed is still the same. Put that here and deploy. And that's basically the same story, with the only difference that those machines were like pre-existing servers, but the rest works basically the same. We can see both clusters have been set up now, so I should be able to just click on the link. Again, self-signed certificate, so I need to accept that. Use my client certificate for authentication. And I'm on the first cluster. So that's the physical one. Now let's open the virtual one for good measure. Here we go. And we're up and running. Now, if I just go ahead and create, let's call it V1, so create a first VM on there, I can pick from our public image server a bunch of different Linux distros directly from there. So I'll take Debian as a VM, and let's just go and create. In this case, it's going to create it on a kind of built-in virtual network and not directly on the physical network. So I just wanted to show that for the first one. Here we go. It's created and it's starting up. We could go see its console, but it's effectively booting up right now. And in a few seconds, it's going to be operational. I'll be able to get a terminal on that. Okay. So shell should work now. Come on. Maybe I was slightly too early. Okay, there we go. So we can see its IP address is 10.172.172 something. So it's not on the 172.17.30. That's the lab. It's running on effectively an internal network right now. That's fine, but we actually want to set things up so we can use the physical network as well. So we can go onto the network page here and create a new physical network. I'm going to name it after the same name that it's got in VMware. That's going to be quite useful when dealing with migrating VMs later. So call it VM network, no description, selecting the right interface. It did it automatically, and then create. And now if I go here and I create a new instance called V2, and let's take another, I'm just gonna save myself the download by taking the same image. There we go. If I go on the network side of things, I can actually change that to using my VM network and create. Also, we can see it's landing on different servers. So the first one, oh, so I created a container instead of a VM. Whoops. So the first VM was on virtual 1. The container is showing up on virtual 2 instead. Let's see what's going on with it. It still works the same way, it's just not a VM. But we can see the IP address this time is 172.17.30, so it is on the physical network. And just because I feel like I'm cheating you by not having created an actual VM, let me create V3 as an actual virtual machine on that network. So that I forgot to select VM earlier, that's why I got a container. And I said network, override that onto VM network and go. That way we're going to have something on each server, so we can see the first VM went to virtual 01, the container went to virtual 02, and the third, the second VM goes to virtual 03. Now, if we go look at its console, it's going to be booting up. There we go. And once booted, again, we'll be able to access it directly on the lab network. One thing that's interesting, as you've seen me use that terminal tab, so we effectively have an equivalent to the VMware tools running in the guest that lets us directly interact with it, not only getting the IP address, OS, and those kind of details, but also getting a terminal directly in there if we want to. So again, we can see 172.17.30. Same thing if we go on the overview, we can see what network it's on, and that's the lab network. All right, so that's the virtual cluster. Now let's go look at the physical one. Not gonna go through all of the same steps, but I'm gonna go at least create the network. So same thing here. Actually just saw a small issue. Yeah, okay, interesting. I forgot to put a network config for this one when it was deployed, so it actually doesn't see the physical network right now. That was a small omission when I deployed it, but that's going to be a bit of a problem for us right now. So let me go and sort that out. I'll do it through the CLI. I think Operation Center can do it through the UI too, but I'm just more used to do it through the CLI. So I'm going to go and reset things here and do remote add. So I'm effectively telling my Incus CLI client that I want to connect to that remote cluster. Fixing the URL that didn't copy paste correctly. Okay. And now if I look at demo, it's there, but it's got nothing running on it. But I should be able to do admin OS on it, system, edit, and I want to edit the network config of each of the server. So that's the first server. And the network config, I'm just looking at what I need to do. So the one that's got the IP address, you can see is ENO2, and we don't need the rest therefore. So we can clear things up to only having ENO2 configured. We should enable LLDP, so that was something else that's missing, and configure the two roles. So we want it to be used for management and for instances. So that config we're gonna need to put on all three servers to just make them configured correctly for on the network side of it. Okay, so that one is done. 2 more to go. Okay, so again, ENO2 is the one we care about. Can remove this flag, can remove, whoops, the other interfaces. Okay, save that. And that's effectively an artifact of those machines being pre-deployed systems. They didn't have that configuration in their initial deployment, and I forgot to apply it before enrolling them. So that's what's going on here. So I'm just fixing that real quick. At large scale, you do that through an API client, so you don't need to do it manually like that. And that looks correct, and that's the last one. And this is happening live, like it's just reconfiguring the config on those 3 machines. So now if I go back in the UI on the networking tab, here we go. ENO2 is now showing up on all 3, which means I can do physical network VM-network. It selects ENO2 correctly now and can hit create. And we get to run a VM on that and make sure everything is behaving the same as it did on the virtual cluster. So create a VM, network, override that, and we want it on VM network, create and start. All right, so it's downloading the image, unpacking, and starting up. There we go. We go look, I'm gonna see the same thing. It's starting up. It's gonna be a bit faster, I expect, because this is running on physical hardware with pretty fast CPUs. Here we go, it's up and running. And once again, it's on the lab network, 172.17.30.198 on this one. And if we go look at the CPU, you can see it's running on AMD EPYC's 64 cores. So you can see it's on the physical hardware with just one virtual CPU exposed to this VM. Alrighty, so we got 2 clusters that are working properly. Operation Center sees them both, that's all good. Now what we want is to move those 4 VMs here over to one of the clusters. So to do that, we're gonna need to deploy Migration Manager. And we do that by once again going onto the tokens view and hitting the download button. So this time we want to download not Incus, but Operation Center. And we can provide some extra seed data for Operation Center, some of which I've got ready again for it. Migration Manager, sorry, deploying the wrong thing here. Migration Manager. And it's very similar to the Incus config, it just tells it to trust my client certificate, since again, we don't have central authentication set up here. And actually, let me go in my downloads folder and clean things up a bit here, because otherwise I might get confused by what is what. And hit download. So now we're gonna get another install ISO, this time for Migration Manager, that we can go and deploy on one of the clusters. I think I'm going to be using the physical cluster to run that one, but it doesn't really matter. It could run on either since they're all connected to the same physical network. So we're going to effectively go and say create a new instance, call that Migration Manager, and we're going to use the use custom ISO option to then upload an ISO into the cluster and install from it. So for that, we need to wait for that to actually be done generating the ISO for us. And once it is, then upload it over to Incus and create that VM. And then the goal is effectively running Migration Manager, adding the VMware cluster on one hand, and adding the two Incus clusters on the other side. And then we could pick whichever cluster we want as the migration target. All right, so the ISO has been downloaded. If I go, come on. Okay, if I switch to the physical cluster, I can do browse, download, select the ISO, and I can give it a name, or it can just use its existing name. It's fine. So uploading that over to the cluster. You can see the transfer is going pretty quick to just upload those 3.2 gigs over there. And then it will do some verification and we'll be able to actually create the VM. Once again, we're going to need the VM to have a virtual TPM, be attached to the right network, and also have secure boot configured correctly. So basically the same as I had done for the three servers that are the three virtual servers on my existing cluster. Okay, so it's uploaded. We can select it. There we go. And then configure the rest. So on the disk side, we're going to want 50 gigs of storage. So let's do that. On the network side, we want it on the VM network. GPU doesn't matter. On the other devices side, we want a virtual TPM. So let's add one of those. Okay. Resource limits, we can bump things a bit. So let's go being quite generous. So 4 virtual CPUs and 8 gigs of RAM. Let's do it like that. On the security side, we need to disable the default secure boot config so that it can go into setup mode and load things for us. And I think that's all that we need. So let's go and create that and start it up. And then give it a bit of time to go through the first boot where it enrolls the secure boot key, then it turns itself off, back on again, and then it boots correctly with secure boot enabled, and then can go through the install process. So around now, it should be on that second boot. Let's go see. Migration Manager, console. It might still be restarting, so just refresh that. Yep, there we go. It's going through the install right now. Just taking a few seconds to install and we'll be good to go. Okay, we're installed. So let's stop that VM. Actually, we can do a clean stop. There's no reason to force it. So let's do a clean stop of that. There we go. Then in the config, I'm just gonna go the easy way with the text version of it, but I want to remove the ISO it was installed from, so just saving that. Then we can start it back up. And go look at the console. Here we go. Not sure why the console disappeared. Let's just refresh. Okay, here we go. So that's going to be booting up right now. Incus OS is starting. And that's effectively its first boot. So that's the slow one where, again, it needs to repartition, do the disk encryption, do all that stuff. And then it will go and download Migration Manager, register with Operation Center, and we'll have that up and running. And generating the recovery key. All right, there we go. Connecting to the network. It's got its host name set correctly now. So ACE61 is that one. It's downloading Migration Manager, and then it will go and register with Operation Center, and we'll be good to go. Yep. All right. So if we go back into Operation Center and on the server list, we've got this one showing up now. I can rename that to Migration Manager here, rename, go look at the server list. And now we can see we've got 3 physical Incus ones, 3 virtual Incus, and a Migration Manager running. It's not clustered, obviously. So it just stays the way it is. And we can click on the link here. Again, self-signed certificates, authenticates using my own client certificate, and I'm in Migration Manager now. So what we want to do here are a couple of things. One is actually uploading some artifacts, which in hindsight I should have prepared. I kind of forgot. So let me go and get them. We basically need 2 artifacts uploaded. One is the VMware storage SDK, which is not something we can distribute, but something that any VMware customer can get from the support portal. So that needs to get retrieved and uploaded to Operation Center. So I'm just actually getting that here off screen from the support portal. Yep. It's called VMware VIX disklib, in case anyone cares. The other thing we need is the Virtio drivers. So that's the link here. Latest version of the Virtio driver. So that's the Windows drivers for when we migrate Windows VMs. So I just need the Virtio Win ISO, downloading that here real quick. And I should be good to go. So artifacts, let's set that up. The first is SDK. Don't really need that. OS doesn't matter. Architecture doesn't matter. Source type is VMware. And I think that's what we need in the form there. Yep. Then we can upload the actual file for the VMware SDK. So I've got it here, VMware disklib. Select that, upload. Okay, so that's the VMware SDK setup. As mentioned, the other thing we're going to need to upload is the driver for Windows, so OS, and we do need to tell it what the architecture is, like that. And I think that's all that's needed for that one. And then in here, again, file, select the ISO that I got, and upload that. It'll take slightly longer, it's a bit larger. And we're done. Okay, so that's the setup for the 2 files that we need, that we can't distribute really with Migration Manager itself. Now on the source side, let's add the vCenter. So let's call it vCenter. What's the IP address for vSphere? It's 172.17.32.03. Okay, username, so that's administrator@vsphere.local I'm using. I think it's that password. The certificate fingerprint, it will prompt if we don't specify it, so that's fine. There we go, it's prompting for it. Confirm, and we're done. If we look at the instance list, it has scanned everything on the vCenter automatically, so it knows what's going on with all of those. On the target side, we're gonna need to add our clusters. So let's do virtual is the first cluster, this guy here. Incus, we're gonna log in with TLS. So I need the client certificate and the key. Let me go back to my files. So client certificate, so that's the certificate here. I need text editor. And then same thing for the key. Open with text editor, and I need to actually switch to SID text editor, and client cert is here, so copy that, and client key is here, so we copy that. Once again, in an enterprise environment, we usually use YDC, which would then just prompt for a user or service account login and then move on with that. So we said this is the virtual cluster, so I'm just gonna copy paste that URL in here and just remove anything but the base of it, and then go and submit that. Confirm the prompt for the certificate, and we should be good to go. So target, yeah, it's okay for virtual. And now let's go and do the same thing for the physical cluster. So Incus TLS, again with the certificates. So this one here, this one here, and then the endpoint for the, is that the physical cluster? Yeah, it is, okay. So the endpoint for that here, clean that up and go and hit submit, confirm the certificate, and we should be good to go with 2 targets. Yep, all good. All right, so I'm gonna do a quick migration. By that I mean we're not gonna be setting up constraints and migration windows and all of those kind of things, because that's what you would want on a multi-month migration project. In this case, we just want to move those 4 VMs as quickly as possible for a demo. So I'm gonna go and create a new migration batch. Oh, by the way, I showed that it had the VMs imported, but also notice the VMware network. So that's why we see VM network. If we go look at the network, we can see all the VMs are connected to it. And if we look at the VM on there, say Windows 2022, you can see some details on what it's running, its general configuration, whether we can do background disk imports, network config, and we can go and tweak some things, adding commands, changing the number of CPU, amount of memory, and that kind of stuff during migration. Anyways, we're just gonna do a very simple migration. So I'm creating a new batch, let's call it demo. I'm gonna move things to the physical cluster. The storage pool on the target is local. We're using the default project since we don't have any others. And then we need to put in place a filter for what we want to select. In this case, they're all inside of a folder called test. So we're gonna go and match on that by doing location matches test. And we can see it updated to 4, which is the correct number that we want. And as mentioned, we're not gonna do anything weird with constraints or migration windows or anything. We just want this done as quickly as possible. So now it's defined. We can go look at what VMs will be moved. And if we go back to the batch list, we can hit start over here. At this point, if we go look at the queue, we'll see that Migration Manager is creating new VMs on the Incus side. So those will just be blank VMs that then will boot off of a ISO that's been generated and uploaded by Migration Manager into the cluster. And those VMs will then boot that and then start a worker binary, which connects back to Migration Manager to get what it needs to begin the actual data migration. So we see this is already happening. It's now creating a snapshot on the VMware side and will begin disk transfers shortly. There we go. Disk transfer is in progress. Now, while this is going on, is a good time to go back to VMware and get an IP address. So let's say this Debian VM here. I'm gonna take that IP address and just go in a terminal and have it be pinged. That will give us an idea for the actual downtime we'll see once we get to the end of the migration. Like as it stands right now, we can see it's still online. Actually make that terminal stick around. Yeah. So as it stands, it's still online. We're still doing the disk transfer on it. We can see actually that Oracle is a bit ahead. That's probably going to be the first one to wrap up its migration, but usually Debian doesn't take very long either, neither does Ubuntu. Windows is the one that's going to take longer just on account of its disk being larger. So as we can see, as this is going on, there is currently 0 impact on any of those VMs. And when dealing with a large, like a complex large migration batch, you're going to have potentially hundreds, if not thousands or tens of thousands of VMs effectively being in that state somewhat continuously. Like every hour or so, it will go and synchronize whatever has changed, just keeping the data in sync. If we go look at our physical cluster here, we can see those VMs have been created. So Debian 12, Oracle, Ubuntu, and Windows. They're running currently on a private network, so not on the actual network that they will be landing on at the end. and they're all effectively running a Debian-based image that we're using for the migration itself. And if we go look at what's running in there, we can actually see a process called Migration Manager Worker here. That's then running nbd-kit and nbd-copy to transfer the data from VMware over to Incus. All right. So if we look here now, Debian 12 actually has completed its pre-migration step, and it shows us waiting for migration window. This will just last a few more seconds. There we go. Now we can see we're offline. It's been shut down on the VMware side, and it's performing the final migration tasks. So those tasks effectively include configuring the network, reconfiguring the network, reconfiguring storage, those kind of things inside of the guest, so that when it boots back up, it's functional. So we can see that currently we're offline on the VMware side. We are not going to be deleting the VM or anything. So if anything goes wrong, we can still restart it automatically on the VMware side. But the VM is currently offline. We're completing the migration, and then the VM will come back online and we'll start pinging again. So if we look, we stopped pinging at 121. So we're about 40 seconds into that. And we can see already it's saying starting target finished. So it should just be now a few more seconds before we see it come back online, and then we can get an idea for what the actual downtime was for that. If we go back here, we should see Debian 12. It's currently booting back up, and actually it started pinging again. So it started pinging again at 179, and it went down at 121. So we're looking at 78 seconds, or a minute 18 seconds effectively of downtime for that VM. And now the others are going through basically the same steps. So Oracle is now waiting to do the final pass. Ubuntu is starting back up, so it's going to hit finished anytime soon. Now, Oracle is going to wrap its thing up, and Windows, we're still waiting to transfer the disk. As I said, that's going to be quite a bit larger. Actually, we've just seen it. It's interesting. We've just seen it jump from 35 to 95. That's because we don't really know how much of the disk is really in use. So depending on the fragmentation and some of that stuff, the percentage is not super accurate. And that's why it kind of jumps like that. Obviously, it doesn't really matter normally because we're doing that in many, many incremental steps over weeks. But it's quite visible when you ask for all of the data to be handled in one shot, like is the case here. I can stop pinging that one and just keep an eye on the others. So Debian, Ubuntu are now done. Oracle is getting ready. So it's been stopped on the VMware side. If we look at this point, Windows is the only one that's still running, but it's about to get stopped because it's just waiting for the next run to get picked up. And yeah, Oracle, the data has been transferred. We just deleted the last snapshot on the VMware side and now running the post-import tasks to reconfigure its network and storage before it comes back up on the Incus side. All right. So yeah, Windows, same thing. It must have been stopped now on the VMware side. And we can see actually in the vSphere log here at the bottom, the snapshots being created, the VMs being stopped, all that kind of stuff is happening on the VMware end. And now Oracle is performing the final migration task, so it's about to complete and reboot. Windows seems to have beaten it to it, actually, and is already booting back up. So we can go take a look at Windows. The reason is simply like how many steps are needed in post-migration. Oracle is a bit slow because we need to regenerate the init.rd for each of the installed kernel due to not having the right drivers. Windows is quite a bit faster. We just need to copy some files into place, modify a few registry keys, and then reboot. So that's why it's ended up beating Oracle on this one. All right, so it's doing its first boot post-migration, so the getting devices ready step that we see just on one boot. It will actually go through another step once it's booted to apply some modified network config as well to make sure the NICs and everything are properly aligned and get the same IP address. Now, if we look, okay, they're all done. So Oracle and Oracle has probably also booted. Windows is just done. So if we try to log in, there we go. Reason for shutdown, yeah. That's because you got migrated. All right, cancel that. And then let's go see what the network looks like. We are connected 172.17.30.18. I actually do have notes on the side of what all the IP addresses were on the VMware side. Let me just find those here real quick. Just making sure. So Windows was on 218, so that lines up. Ubuntu was on 219, so let's go see what that got now. 219. Oracle was on 214, it's still on 214, and we checked Debian as it was happening, so 226 for Debian. All right, so everything migrated, everything at this point is stopped on the VMware end. The migration here, everything is marked as finished and being all done. Which means the batch itself is also now in finished state. And that's how you move the content of a vSphere over to Incus. Obviously, we could have done like smaller batches, played with two different clusters, played with some affinity, anti-affinity rules, a whole bunch of things. But for just the basics of taking a bunch of VMs, moving them over and starting them back up, that's what it looks like. All right, let me get back to some slides over here. So just moving back to this, there we go. So that was for the demo, like effectively deploying the entire stack on both virtual and physical clusters and doing some VM event container creations and then an actual migration of real workloads from VMware over to Incus. All right, so the next steps, that's effectively, if you were in a production environment, what would the next steps look like at this point? So that's where we'd normally go and, as mentioned multiple times, would integrate with authentication and authorization systems. So that's OpenID Connect on the authentication side that then connects to something like Microsoft Entra or Okta or any of the other standard OpenID identity provider stacks out there. On the authorization side, we use OpenFGA, which is Open Fine-Grained Access Control, and that gets synchronized with the right source of truth for access and group membership. Or again, typically synchronizing groups with Active Directory or Microsoft Entra. On the monitoring and observability side, we usually like using the Grafana Enterprise stack with Prometheus for metrics, Loki for logging. We also support plain syslog logging for any environments that has extensive use of that. On the network side, I mentioned it a couple of times too, but normally we would want DNS records allocated to everything. And we would want the clusters to be behind a load balancer so that if some specific servers go down at any one time, it doesn't matter. The clients always interact with machines that are actually online. On the security side, we normally ask for valid HTTPS certificates on everything, just to avoid potential man-in-the-middle attack or that kind of stuff that happens from using self-signed certificates everywhere. We'd also want to integrate with backup systems. We've got a built-in backup API for all of our VMs and disks, which can either produce an internal tarball that then needs to be pulled into a backup system, or we support pushing to an S3 bucket for any backup system that has a built-in S3 API that can be used by applications like ours to back themselves up. And also integration with the infra as code side of things. So as I mentioned, each cluster has a convenient download button inside Operations Center to download a zip file of the initial Terraform data for that cluster. So at that point, the cluster is effectively read-only from the point of view of Operations Center, but you can download that Terraform, that set of Terraform files, put that into your infra as code pipeline, and then any changes you're doing from that point on, you run through your normal infra as code pipeline. All right, and that's effectively it for this demo. and this overview of the FuturFusion Cloud stack. So FuturFusion Cloud is an enterprise-grade, fully open source private cloud stack. As I've showed, like every single thing I've done is something you can repeat for yourself, from downloading directly from the public website to running through deployment and all of those steps. FuturFusion, the FuturFusion team is really here for providing all of the enterprise services that go along it, from initial analysis of the environment, providing training, providing support, and standing behind this software stack and making sure that you get timely fixes and security updates on the entire stack. The stack itself is highly available, highly scalable. The clusters here were all deployed with at least 3 servers, which means they are fully HA. So you can have any of them go down at any time, and the remaining servers will keep going just fine and will be able to actually recover the workloads that have gone offline due to a server going down. We've got tooling to very efficiently and safely migrate off of VMware. That was Migration Manager that you've seen move a number of VMs away from VMware and onto Incus. Everything is infrastructure as code ready. So everything, we always build REST APIs. There is no such thing as a separate API just for our CLI or for our UI. Everything is using the same public facing REST API. So anything that you can do through the CLI or through the UI, you can also do through your own automation by using our APIs. And everything is designed to be as secure as it gets, from limiting the amount of information that we have. We don't have local accounts, we don't have local login and passwords, we don't store any personal data for the users. We entirely rely on external authentication authorization. We do have recovery mechanisms like using a TLS client certificate that we would then normally recommend be stored on a physical HSM and then put in a safe somewhere. We also use UEFI secure boot and TPMs everywhere to validate that all of the machines in the stack only boot the software they're supposed to be booting, and that everything checks out before any of the user data can be accessed. And as I mentioned, FuturFusion as a company provides 24/7 support worldwide on this stack, training services, professional services, analysis, and everything you would expect to run very large enterprise-grade deployments of an open source private cloud stack. And that's it. You can go look at some more details on the stack on our website, and if you want to reach out to our sales team, the email address is here too. Hopefully this was interesting to you as a good way to get introduced to the FuturFusion Cloud stack. I obviously didn't get to go into much details on any one of the components, but hopefully this overview of how they all fit together and how everything works together was useful. We do have other videos and other material that goes much deeper in specific components, things like Migration Manager, things like Operation Center, and obviously everything that Incus can do as a private cloud platform. Thanks a lot for watching, and I'll see you in another video.